Well, thank you all for showing up. It's been quite a journey over the last several years working on these products. The needs, requirements, verification, validation, lifecycle manual. It started out as the needs and requirements lifecycle manual. That's what it was last IW. We've added verification validation because a lot of the manual talks about verification validation. I don't think there's a chapter that doesn't mention verification validation in some context because we want people to think about verification validation across the lifecycle as well as the needs and requirements. This is the version of the guide that was submitted and hopefully be in the store within the week. Its purpose is to supplement and elaborate on the INCOSE System Engineering Handbook. The handbook for each process area is very page constrained, about 4 pages for each process area at the max, but sometimes 3 pages. And so it has highlights, but a lot of the details that people like to know about aren't there. And so the manual and the guides are going to help with that. And so we had a more detailed guidance of what, how, why concerning needs, requirements, definition, management, and verification, validation across the life cycle. We're a little bit sloppy as engineers in our use of terminology. And so one thing at the front of the manuals, we talk about some of this ambiguity and inconsistencies and how we use certain words and phrases. So to put everyone on the same plane when it comes to understanding of what we're talking about. And it talks about system engineering lifecycle concepts from the perspective of needs, requirements, verification, and validation, and the management of those across the life cycles. From a requirement working group standpoint, that's our perspective. Other groups have a different perspective of system engineering, but this is our perspective. A key thing here is to successfully complete system verification, system validation. The needs and requirements of the system, as well as system verification and system validation artifacts, must be managed throughout the entire life cycle. And so we provide that practical guidance of the activities required to achieve those. The manual is quite comprehensive. It's 470 some pages. It provides a general framework, but its intent is to give people ideas, and then they can tailor what's in the manual to their specific product line, how they develop the products, their culture, their processes. There's some good ideas they could use to update their existing processes. The overall saying here is needs and requirements, verification, validation are the common threads that tie all lifecycle activities and processes together. So the table of contents, section 1 goes through a basic introduction. It talks about the different activity areas. I really didn't talk about process areas as much. The processes are defined in 15288 and defined in the System Engineering Handbook. And then we're elaborating on that for different activities that you do as part of those process areas. And that's where some of the general terminology issues are talked about in that section. 1.5 just goes through the overall organization. Section 2 is definition, terms, and concepts. 2.1 definitions. A lot of that came from the existing guide for writing requirements, been updated. We talk about lifecycle concept needs and requirements, the applicability of those across the lifecycle. And then a big discussion was levels. And again, part of this is from the guide for writing requirements, but it's expanded considerably, where we talk about levels of organization, system architecture, hierarchical view, and then the need to really have a more holistic view of the system, and then how to use both of those. And then section 2.4, verification, validation, and context. A lot of that was pulled from the guide for writing requirements, section 1.7, and expanded. And then we talk about integration, verification, validation as it compares against the traditional SEV model. And that's where some of the CAB concerns were and how it was viewed and some changes they think that we should make, and we address those. You know, section 2 is the set of kind of underlying baseline of key concepts, reducing the risk of addressing system verification and validation early. You don't want to wait till the end to think about it. The importance of doing this with an integrated, collaborative, multidiscipline project team, importance of effective communications. Talk about greenfield versus brownfield systems, because it's an important distinction to a lot of organizations. And that's where part of the tailoring is going to be. If your organization is primarily a brownfield where you're modifying existing systems, then you're going to modify a lot of the activities based on that type of a product line. For those that are developing products from scratch, they'll go with more of a greenfield approach, and then you'll view the activities differently. There's a lot of detail in here, a lot of different activities. Some people say, hey, we don't want to do all of that. We don't have time for it. So we introduced the concept of technical debt. And basically technical debt is you take on a loan, if you don't do certain activities when they should be early, you're going to pay dearly later on with interest, because you're going to end up having to do those to be successful. The later you wait to do some things, the more issues you're going to have. And then we go into an overview of system engineering as discussed in the manual. Section 3, a lot of that was taken from that integrated data as a foundation of system engineering. The big message there is, one is that we need to move from a document-centric to a data-centric practice of system engineering, which we maintain is the real intent of MBSE. The INRDM is the information-based needs requirements development management approach. Then we also talk about the duality that was presented at one of the IWs, where textual needs and requirements are needed, but so are models and diagrams. And so they're really two sides of the same coin. And we talk about each one of those. This diagram currently is in the System Energy Handbook, the introduction to technical processes. It's going to be replaced by one of our other figures. When you look at the different levels of organization, we have the business requirements, business operation requirements, and system requirements. The manual really focuses on the system, subsystem, system element level parts of the architecture. No matter where you are in the architecture, this all applies. And no matter where you are in the architecture, whatever level you are, there's going to be real world stakeholder expectations. You're going to have lifecycle concepts, needs, and requirements that kind of exist no matter where you are located in the architecture. One of the big things that we talk about, rather than thinking serially, like is kind of implied in the V model, we do a lot of the activities concurrently. Iterative, recursive nature of system engineering. That's where the integrated collaborative multidiscipline project team consists of both project management and system engineering people throughout the life cycle. And really, by doing this concurrently, you can apply a lot more, maybe the agile approach in some cases. And so it's going to be faster and cheaper than the classical serial view of using document-centric processes. It also aids in establishing correctness, completeness, and consistency of our artifacts. And we'll talk more about that also. Another thing is that a lot of people, when they look at the V model, you're used to IV and V, integration, verification, validation, as something that occurs on the right side of the V. But in reality, integration is something that should be occurring across the life cycle. We need to be managing our integrated systems from the very beginning and not wait to worry about integration activities on the right side of the V. No matter how you implement the architecture, how much you do in-house, how much you outsource, you still got to manage the integrated system. System validation is something also that we want to make sure that we do across the life cycle. Stakeholder needs is what we validate against. So we got to make sure that we have defined those well. They're transformed in the design input requirements. Got to make sure that then they're validated to communicate the intent of the needs. And the same with the architecture design, our design output specifications, what the system is built or coded to, and then the realized system elements, subsystems, and integrated system are going to be validated against those needs. By doing more validation and verification activities on the left side of the V is one of the big things that the CAB was really worried about. The idea is, and it's really enabled by the use of models that exist within requirement management tools, the traceability, and so on.
Hey, Lou, you're talking about models, and I hate interrupting you in thought, but you're right at Pascal's question. Why assuming requirement representation are textual and not executable model and diagram? And I know the manual addresses this, but just if you can want to either answer that now or answer it when you're done in a bit. I thought that was a great question.
Why do you need textual requirements?
Versus it's almost like one or the other, and I think there's a place for both, but I wanted you to answer that versus executable model and diagram as requirements.
I really don't have time to go into that. One thing you can do is read section 3 of the manual. It has a list of why textual requirements are going to always be needed and what they're used for in what cases, and how models aren't well at doing certain things. But then it also lists, here's all the advantages of using the models as really analysis tools that give you that underlying analysis from which the requirements come from. And I know people talk about wanting to just do away with textual requirements, but the reasons for not being able to really do that, where it's not really realistic, is listed in that section of the manual. One of the things that we've done over the years, we've evolved this diagram. And now that a version of this is going to be put into the System Engineering Handbook, one big thing that changed is on the ends. Our job doesn't stop when we've built the system. Our job continues after the system has been fielded, it's being maintained and eventually disposed. On the left, there's stakeholder real-world expectations, which is the real source of truth of what is expected of the system. When we define a set of needs and requirements, those are only approximations. They really communicate as understood and as communicated, but they may not be exactly the same as what the stakeholders really wanted. And then over time, it may be that the system's out there, but it fails to meet the system validation. It's not really doing what it's intended to. The operational environment may have changed, the users may have changed, and so we need to be monitoring that. And from a verification standpoint, system degrade, and over time, they may not even be meeting the design input requirements. So there's post-development verification validation been added to this. If you're in the medical device world, there's a thing called design controls. And we've always had these orange boxes in our diagram talking about the organizational view of how we do the different activities. And so we need to recognize that the project team is driven by those requirements and processes as well. This encompasses the end-to-end thing, and this applies to your system of interest, no matter where you are in the overall integrated architecture. And we talk about integrated set of needs that represent the stakeholders' perspective of what they really need from the system, looking at it as a closed system, or some people call a black box. And then we transform that into a system perspective, which the design input requirements represent. What does the system need to do to meet those needs? The term design input requirements and design output come from the medical device world, but I think they really apply to any industry. And the lines in here to make that distinction, a lot of problems that we have with our requirement sets is people mix up design inputs with design outputs. You'll see a really big bloated set of requirement documents, but when we look at it, you see there's a whole lot of implementation. And so this concept of the line, when we're talking with people, you say we're above the line right now, we're talking about the what, not the how, and not the implementation of it. So we have that distinction in our terminology. And the bottom is doing all these different activities concurrently as we're going across the life cycle. And so the data-centric practice system engineering is one thing we really emphasize. It needs definition. There's a lot of activities to do through an analysis with defining functions. We want to focus on interactions with the outside worlds, the interfaces. We have different requirement expressions. And that's one problem with modeling, is modeling tends to be more centered around functionality and interactions. But there's a whole other set of requirements, the quality requirements, requirements dealing with compliance with regulations and standards that often aren't addressed as well in the functional world because they apply to the physical world. That's one answer why we need textual requirements, because there's certain types of requirements that aren't communicated well within a model. And especially if I have 500 requirements, it's really hard for me to go and grasp 500 requirements just by looking at a set of diagrams in a model. All this is linked together. Traceability is key. All the sources of the needs need to be traced. The transformation of that into the requirements is traced. We define our system verification artifacts. We have the physical architecture that's traced to the engineering system. We have system validation artifacts. And then the blue is, we have our models. We have a functional model, architecture model, physical architecture models. We have behavior models and interaction models. So there's a lot of different kind of models. It's impossible really to model the whole system. The only real accurate model of the whole system is the system itself. Other models that are developed for a specific purpose, and those models themselves have to go through their own verification validation to make sure that they accurately represent what they're supposed to when they're developed. A big focus is needs versus requirements. Really understanding up front what the stakeholders' view is first, and then the technical view that the requirements have. Historically, a lot of people focus more on requirements because in an acquisition world, what you're given is a set of requirements. So we're going to go and meet that. But you can build a system to meet the requirements and fail system validation because you didn't understand the stakeholders' real world expectations. And you left out certain things. You left out the driver's constraints. You left out all the different stakeholder perspectives across the different life cycles, and you end up failing system validation. So we need both perspectives. And so the manual really spends a lot of time on the needs piece and then transforming that into the requirements. Rather than focusing just on requirements, we got to focus on both needs and requirements. So you'll see throughout the manual, it talks about needs and requirements. A lot of papers written by different people quite a while ago, and they all talk about requirements analysis and writing requirements, and they never really mention the needs piece of it. And so that's one big difference. And then also the focusing on verification validation early when we're writing on our needs and requirements is really important. I worked with one project where they didn't really think of that. And then they found out, probably 50% of our budget's going to be involved in just system verification and validation, and we didn't plan for it. And that was a big problem. We have to take a holistic view of system engineering where the needs, requirements, verification, validation are managed in context of all lifecycle process areas rather than in distinct silos. We talked about the different levels of hierarchical view. This is typical where you're going to decompose the system and do further elaboration. The color code here is such that what's called a system element, the project has decided not to do any further decomposition or elaboration, and they're ready to hand that off to the design team, whereas the blue boxes are things that are further decomposed by the project. And there's not an equal amount of decomposition in all the levels in that case. But the key thing is you see CNR in all of these boxes. So that stands for concepts, needs, and requirements. Should be defined for all of these. They're all related. So again, traceability is key, that we link all this information together when we're developing our set. A set of system requirements and a set of system needs is not just what was defined at the system level. The set of concepts, needs, and requirements is the sum total of all of these concept needs and requirements for our system. And again, to manage all that in a document-centric world is almost impossible to keep everything consistent. So again, why it's really important that we go to a data-centric practice of managing all this. And the flow down requirements, the allocation, the budgeting piece is really important. Section 4 goes into the lifecycle concepts and needs definition. The guide for needs and requirements that Tammy's working on, that's what its focus is on section 4, 5, 6, and 7. Section 4, we go through a whole bunch of different activities that are done in doing this. To define the needs, there's a whole lot of inputs that we have to consider. We come up with a set of lifecycle concepts through analysis and maturation. The big thing there is coming up with something that's feasible. And when you look in the guide for writing requirements, one of the characteristics of needs and requirements is that they're feasible, but feasibility is in the physical realm. And so we're going to have to do some architecting, some design work early, and we're going to have to be able to identify what the critical technologies are to meet certain expectations for performance and capabilities. And so our models start during this stage. And out of that, when we've identified at least one feasible set of lifecycle concepts, then we can define an integrated set of needs. So there's a whole lot of work done before defining requirements. And the needs is just communication of all that work. And we're going to validate against it. But by focusing on that, it's going to help us establish completeness, consistency, correctness, and feasibility before we transform those needs into our design input requirements. I don't know if Susan Roning's on right now, but one of the inputs that she made early on when we were writing the guide for needs and requirements in its other form, in her inputs, she presented a diagram like this. And I really like that way of communicating the activities. And so this shows the different activities being done. The section numbers are sections then in the manual that elaborates and goes into detail in each one of these. This is an extension of that. So the first part was to gather the information. The second part then is to do the analysis of mature life cycles. Out of this, they're going to come up with people needs against the organization, the projects, process needs, work instruction kind of things, instructions for use, and then needs that have to do with our actual system itself. And so we would go through and define and record those needs, plan ahead for system validation, verify and validate the needs, baseline and manage those needs. And then that feeds into our requirements activities. So the section number here is all sections within the manual. A big emphasis on using different types of diagramming and modeling techniques to better understand our system. These are all diagrams you can actually do in PowerPoint if you want. And I've seen for less complex systems, they do that. But for more complex systems, you're going to need a language-based modeling tool to assist in this. And there's a lot of different tools that allow you to walk through these diagrams in series for that. The whole thing about the lifecycle concepts is that it's a iterative process and there's going to be several cycles. Now, this is not the spiral development thing. It starts in the middle and goes to the outside. This is the doctrine of successive refinement, which I first saw in a NASA document several years ago. Basically, you start out with kind of a broad view and you zero in on the solution. There's separate sections on each of these, and you may have to go through multiple cycles in order to come up with the end result. And so we have defined our set of needs. There's a lot of sources that they're going to be traced to. Like I said, there's a lot of work that we're going to do before we actually can define and baseline the needs and then transform those into the requirements. So section 5 gets into the needs verification validation. And we want to know if the individual needs have the characteristics defined in the guide for writing requirement. Does the integrated set of needs have the characteristics for the set? Have the attributes defined for each need statement? Are all the need statements traceable to their source? And did they clearly communicate the stakeholder expectations? And this is a diagram of that needs verification validation. And this diagram is included actually in the manual, and that's what we walk through. Section 6, the design input requirements definition. This assumes that we're doing a data-centric practice of system engineering. It assumes that we have defined a set of needs that we're going to transform into the design input requirements. There's an IPO diagram for each one of those, which Tammy will show in her presentation. One big thing about all this is establishing traceability. So there's a section that goes in a lot of detail on just what traceability is, defining interactions, recording interface requirements. So the section goes in a lot of detail on the interface identification, definition, and writing interface requirements. The use of attributes, the developer manager requirements, the importance of planning ahead to system verification. How are we going to obtain the evidence that the built system actually implemented those requirements? And then we finalize that, baseline that set of requirements. But then we have to consider that depending on where we are in the architecture, those requirements might be flowed down to the subsystems and system elements at the next level of the architecture. So we have the flow down allocation budgeting concepts. Budgeting is where we're budgeting different quantities. So if the overall system, it has some mass, how do you divide the mass up amongst the systems? But like in a software-centric thing, maybe when you're talking about a medical device that's doing measurements of a biological sample, then at the system level, there's maybe an expectation for overall accuracy and precision. Well, how do you allocate the accuracy and precision down between the hardware elements of the system, the software that's doing the analysis, as well as the actual biological sample and reagents and stuff that are associated with it? A lot of the quantities that we have, when they flow down to different levels, they have to be budgeted and allocated. So it goes through all the different part of this. And then the last section, the summary of what we've done here. This is another one of the diagrams that talk about all these activities for the design input requirements. And it recognizes that there may be an architecture where we're going to go down for our system elements that need no further decomposition. Then they're going to be handed off to design and then production. Like I said, there's a lot of work done on interfaces. And one of the big problems that we have in a holistic view in our software intensive systems is the number of interfaces have drastically increased. And so the importance of focusing on the interactions across interface boundaries is important. And the manual talks a lot about that. Moving between levels, a different view of the diagram I showed earlier, where we have requirements that flow down from one level to the next. At the organizational levels, these first two levels, we have the business requirements, business operation requirements. They'll have a mission statement. They define the problem. That all constrains what's being done at the next level. Section 4 talks about lifecycle concepts, needs definition. And you define those. And then section 6 is going to be the requirements, but then they flow down to the next level, the subsystems. And we go through the same process again for each of those. And then they all flow down to the lower level system elements. No matter what your system of interest is, you can use what's in the manual for that. From an architecting standpoint, and we talk about maybe a little bit different approach, especially for software-centric or software-intensive systems, where at the system level, rather than decomposing into subsystems right away, we may decompose into hardware, mechanical, software, and there's a lot of interactions that take place, a lot of interfaces. And then those will be decomposed to more our classic subsystem system elements. For the example I just gave for the medical measuring device, the instrument itself would be here on the left. The biological sample, the assay, would be in the middle, and then the software that's going to do the analysis would be on the right. That way the software gets their requirements allocated to them much earlier in the life cycle. That's important in today's system, where software intensive systems are really the critical path for being able to develop a system. And Section 7 talks about our design input requirements, verification, validation. And again, requirements verification, requirements validation is about the quality of the requirements. It's not about verifying the system meets the requirements. That's what we call system verification. And so again, we want to make sure that requirement expressions have the characteristics, and the sets of requirements have the characteristics. We define the attributes, assess traceability, and do they communicate the intent of the needs from which they were transformed. This is a blow up of just that one section of that overall diagram of requirements, verification, validation. Verification, validation is always you're verifying something against something. We're verifying the design input requirements against the organizational requirement, definition requirements, like the guide for writing requirements or a similar guide. We're validating that they meet the intent. And this is where the I2V picks up design verification, design validation, talking about the fact that you can do early system verification validation. Model simulation are going to be a big part. The idea is to be able to find issues with your proposed design before you actually build code stuff. And it's a lot cheaper to fix those at this point in the life cycle than to wait until the traditional on the right side of the V, when you've built stuff and you find problems, then you have a lot of rework to do. So we want to move a lot more of this activity earlier in the life cycle. A lot of this is to answer what the CAB's concern was for this. Again, the design is going to go through multiple design cycles to come up with this. This is a blow up of just a section of that one drawing, talking about design, verification, validation. And then we also talk about production verification validation. Some system engineers don't pay much attention to this because that's more of a quality function for a lot of organizations. But once the system's been built and coded, we got to verify that it was built per spec, and we want to make sure it was built per the organizational system realization requirements. And production verification is important because if you're building a lot of things, this is ongoing activity that occurs on the assembly line. We need to be thinking about that as well. And then section 10 and 11, when we talk about system verification, system validation, system verification, did we meet our requirements? System validation, did we meet the needs? There's a lot of common principles. And so section 10 goes through this and walks through the different stages. And then system verification, system validation processes themselves are talked about in section 11. The basic stages, the planning stage, defining, executing, reporting, approval stages that we go through. There's a lot of artifacts that are talked about in going through this that we have to develop. The word instance comes from the modeling world. And so each need and each requirement is an instance. And so we have to define success criteria that needs to be met by either verification validation, that the system has met that need or met that requirement. We have to define a strategy for doing so, define what method we're going to use, the test, demonstration, inspection, analysis. We define activities that are going to make that happen. Activity could involve more than one requirement or need. Then we're going to have procedural requirements, and we're going to develop a procedure. We're going to schedule those events in the project's master schedule. Those are going to be performed. We have an execution record that records what the results were. Those are combined into an approval package given to approving authorities. In the end, we have our qualified, certified, accepted system of interest. Talk about defining this information. It's something that needs to be done for each need, each requirement. So there's a lot of work involved in doing this. Section 12, we have to talk about off-the-shelf systems and modified off-the-shelf systems. This section was based on a paper that Tammy wrote as part of her doctorate activities. And then a big thing that we have to worry about is just what is that customer-supplier relationship when we're developing products. especially in terms of verification validation, who's responsible for what, and the importance of making sure that we look at the different kinds of contracting mechanisms and how those are addressed in the contract. And then also one big problem, that is the evolutionary nature of interface definitions. As design inputs, we can identify what the interactions are, but how the systems are going to actually interact with each other are really below the line design decisions. And so when issuing a contract with different suppliers early on, they could have different subsystems as different system elements, but how their system elements are going to interact may not be defined until later in the design cycle. So how do you deal with that uncertainty when you issue the contracts? Now, section 14 goes into detail on needs, requirements, verification, validation. Tammy does a summary of this in the needs and requirements guide as well. This is a diagram that shows all the stuff that we did before in the different sections, how it all feeds into this management process and all these different activities. Section 15, we talk about attributes. This is pulled from the guide for writing requirements. Section 16 features the SE tool set should have, and this was pulled from the integrated data paper. One thing about the attribute section is that 15.5 is something that was new. Talk about product line management. A lot of organizations in product line management, they have different variants of a product. In addition to the product having variants, they're going to have needs and requirements that have variants. And so there's different attributes address that, and there's a discussion concerning all that. That's a very quick fire hose overview of the needs, requirements, verification, validation, lifecycle manual. Tammy, do you have any more things that you can bring up?
Thank you, Lou. That was a great comprehensive overview. And I'm really appreciative that you walked through the table of contents and really walked people through what they can find in each section, because I think it's really important to highlight to people. This is a lengthy manual. People will potentially get intimidated by the sheer volume of information, but really our goal is you can find what you're looking for. You don't have to read it cover to cover. You can go in and figure out what specifically you're interested in solving or tackling and go and read those sections. And I hope people recognize this is a lot of information, but we certainly think that everybody can get something different out of it. Now, there have been a few questions in the chat, and I'm going to quickly go through some of them. Hi, May. Thank you. We really appreciate your comments in the chat, and I know you were addressing some of Pascal's questions as well. Thank you for the compliment. I really appreciate the fact that you have been reading this manual and going through it. Are there any takeaways, since you have been diving in this material, that you just want to share with the team?
First, hats off to everyone in the group, because I really found it very valuable, all the content that you're putting together there. From my own practice of system engineering, I've seen the limitations of the bad practice of requirements engineering, and especially what you're trying to introduce of, the necessity of passing first for establishing the life cycle concepts and then the need analysis in parallel with that before moving to actually doing the requirements. So that's something that I really value from the manual. So as Tony Williams that I see in the chat said, it's a must read. Everyone should be aware of this manual.
Thank you. And I appreciate you engaging in the chat and answering some of the questions, which really kind of helps us, as we actually don't have a ton of questions that I can see through the chat now, but we have a few more minutes before I want to go ahead and start taking on our next topic. Pascal did ask, do we have an analysis of equivalent initiatives in the industry? And I'm assuming similar documentation that addresses needs and requirements. Lou, what do you think? I haven't seen a lot, which I think why we ended up putting stuff together. But have you seen anything comparable?
No, nothing like this. In the past, everything is based on, let's jump right into the requirements. The pink elephant in the room was the needs and system validation. Everyone's really big about system verification, although they called it requirement verification, but they really meant system verification. And so there's a big hole. I taught requirement classes for years. We talked about scope definition up front. We never talked about defining an actual set of needs. We talked about the elicitation, but it was requirements, elicitation, it was concept of operations, and then we magically ended up with a set of requirements. And we kind of skipped a lot of the details that were in that. And so that focus up front When you look at a lot of literature, people say, the whole purpose of this is meeting the needs. But then when you say, well, where are the needs documented? What form are they documented? Are they actually put under configuration control? And I get blank stares. And then Tony made a really good comment in the chat. And one of the problems is that the supplier may get a set of requirements, but they're not given the underlying analysis. The customer really doesn't give them a well-defined set of needs. And that's problematic because if you don't have that stakeholder perspective, then how do you even do system validation? And so the supplier is kind of set up, well, all we can do contractually is meet the requirements. We can do system verification that would show that we met the requirements. But again, you could build the wrong thing. The customer asked for a unicorn, but what was delivered to him was a horse, and the customer wasn't happy. It wasn't really clear what the customer's needs were, and so developers had to make a lot of assumptions just based on what was communicated in the requirements, which didn't adequately communicate what the customer really wanted. The customers need to spend more time up front doing this analysis before they issue contracts. And the Government Accountability Office has said that for years for government contracts, that the government programs need to spend that time up front, and they don't. I see that Susan Roning signed on, and I do want to thank you, Susan, for giving me that idea for those diagrams, because they are used to really give a roadmap throughout the whole manual.
I appreciate that, because I mean, I still struggle with trying to do this. So I thank you for creating those diagrams, because they were helpful to me.
It was your idea. You contributed more than you think you did.
And it's interesting because Susan, I do remember our initial conversations a few workshops ago. And even back then, people were raising a lot of great ideas to us. And a lot of it's just been infused in through this naturally over the last few years. And I really wish I could credit every single person who's done contributions, because there's been so many people. But I definitely remember great lively discussions in person a few years ago. And I welcome those on the line now to continue that. If you start using this material and you start thinking about things that could make it better or more useful, we are certainly going to keep these products living. Even though we'll have a version of it go out now, it's by no means finished. I know we're going to get some user community input, and we'll continue to improve it.
That's an important point, because there's so much in there. Every time I read through it, I say, how did I miss that? And so I'm going to keep a red line version of it. And when we have key ideas, that'll be reflected. Just like a discussion, someone's reading and I had the word proof in it from a verification standpoint. And they said, you don't prove anything. And so I went through the whole document and I got rid of the word proof completely based on that, because really all we can do is provide evidence that can be used to show that the system has met something. It's not proof. It's just, here's the evidence. You have to make your determination with it. And then I had the word document in there several different places. And someone says, well, moving to Data-Centric, we shouldn't use the word document. You won't see the word document, I don't think, any place in the manual. We have sets of requirements that are organized along with the architecture that defines each of the system of interest, the pieces of the architecture. But as like Tammy says, as people start using this, they may have some examples that we could add. They may have a slightly different take that we didn't think about before, and we need to include that in the manual. As you're going through it, please send us emails about any suggestions, and we'll keep all those in a separate file.
I also think the back of the manual also has a comment form. Is that correct, Lou?
Yes, that's a formal INCOSE kind of thing. People can use that if they want, or just send an email. Make it easy.